Hello students, today we are going to discuss our new topic, that is your energy. In physics, this energy contains a vast area, means huge levels of energy we have from class 6 or 7 onward. So, what is the concept of energy? As we know that all living beings perform some basic activities for their survival. They need to change the place from, need to change the, take the shelter from weather, from wild animals, as well as they move here and there in search of food. They do some cultivation, do some agricultural work to produce some food. We are doing some right now. We are doing some job. Your job is for study, or my job is for guiding you to clear the concept. So we are doing some activities for survival. So these types of energies, these type of activities are required some energy. There are different types of activities. In one activity we need, suppose we are doing some exercises, we need more energy. We are simply reading, or I am simply giving you explanation, it takes as less as that exercise. Means I am using this device to deliver the speech. It need, for me it needs less energy, only for me, not my phone or not your phone, but for me it's less energy, because I am simply giving a speech, not heavy exercises, and you are simply listening, not doing any heavy exercises. So some activities require large amount of energies, some activities require less amount of energy. From where we obtain those energies, what food we eat, from that food we absorb some energy. Now, if any work, any activity require energy more than we human producing, then for that we take some help of animals, those having more energy than human being. And if we do some more heavier work, which is not made by the energies of your animals, like your bull, your other horses, so we need some machine. Means all these concepts come from the energy. That energy is useful for doing some performance of activities. Now, what physics says about energy? Energy is nothing but ability to do work is known as your energy. Is the ability. Energy is ability to do work is known as your energy. Now, this energy performs some activities. For example, hammering a nail on a wall by using your hammer. In doing that, what we obtain? What we observe? We observe that if we are using hammer to, suppose this is a nail, we are using hammer to penetrate the wall so that this nail can fix inside the wall. So we use energy to bring the hammer forcefully up to that point. At this condition, when the hammer contact with this pencil, this condition, all the energy consumed by hammer transformed to the nail. Though nail is a smaller one, having, as compared to its body, having large amount of energy, so that it can easily penetrate the wall. This is the concept of doing work with your energy. Now, by doing this, it says that the object which does work. In this example, hammer is doing the work, so which does the work loses the energy. Means I am hammering the nail, so all the energy absorbed by hammer transferred to this nail, and energy becomes zero when it collides or come in contact with nail. The, the object which work does which does work loses energy. At the same time, the object on which work is done, suppose hammer, we are taking the example of hammer and nail. So hammer is the object on by which we are doing work, nail is the object on which we are doing work. So energy is transformed from this hammer to this nail. This is a transfer of energy. Hope this concept is clear. In sum total, energy is always equal, but in this case, energy transfer from hammer towards nail. This is the transfer of energy. This is your transfer of energy. So likewise, we can do the work by using energy. Now question comes that what is the exact definition of energy? It is a capacity or ability of a body to do the work is called energy, and from this we can say that the sum total amount of work done by the energy is numerically equal. Means the amount of work done is always equal to the energy applied. So this is the concept of energy. Now again question comes that what is the meaning of work? So let's discuss what is work. Now what is work? We are going to discuss about work. This is the ability to do work is called energy. Now work, according to physics, work is said to be done when a force applied on a body and that body moves in a direction of the applied force. Suppose we have a body like this one, and one force is applied in this direction, means that side. We are pushing the body likewise. So what happens if this force is able to shift this body A, say the name of the body A, or you can use your body. We shift the body A from this place to at least this place only, the same body, then we can consider that by applying a force we can shift the body, so there is a work done. Physics says that work is said to be done only when we apply force, when the applied force causes some displacement of a body in its own direction, means in the direction of force. This is the work done. So what is the work done? Work equals to, let's say work is said to be done. I am adding short. You must consider a book to write down a definition. Work is said to be done only when applied force, when the applied force causes some displacement causes some displacement of the body in its own direction. This is your work done. Means we are applying a force and on a body shift its place from this to this side in the direction of the applied force. Likewise, this is action. We apply the action force. We try to push up to this pin part. So this is the work done. So work done depend on two conditions. There are two conditions required. One is force applied and other is body must move in the direction of force. Fact conditions are first, there must be a force. Without force, no force, no work done. There must be a force acting on body, nowhere else. Acting on body, on which we are going to do the work. Acting on body. That's why my writing is a little bit changing. And second, body must show some displacement. In the direction of applied force or force. So this is the concept of energy and this is the concept of your work. So your chapter name is energy. In energy we discuss energy as well as work because this work term comes under the definition of energy. So these are the factors. Means there must be a force, there must be some displacement. Now mathematically what work said? Mathematically, work is a product of force and displacement through which force act. Means if you are applying a force on a body this side, body shows some displacement along the direction of the applied force. So this shows some work is done. Clear? So work is a product of force. Work is a product of force and displacement caused by the body in the direction of the force. So mathematically we can write down work done. Let me come this side. Mathematically we can write down work done W. If work done is W, then this W equals to force applied on body and the displacement occurred by the body in direction of force. This is the formula for finding the force. But so come to the formulas or definitions. As we discussed all the definition of energy in work. Now, what is the unit of work or energy? Always remember that in case of work, the SI unit of work is joule. Let me clear this one. Okay, now what is the unit of work? So SI unit of work is joule. Is joule. SI unit of work is joule, as I discussed in just a few minutes ago, that numerically energy and work done are equal. So always remember that total amount of work done by a body is numerically equal to its energy. Suppose we are doing applying energy, or what we have energy, that amount of work can be done by me. So you can remember that. And so unit of work and energy is same, it's a joule. So this is the SI unit of work or energy is joule. What is joule? Or question may ask you sometimes, define 1 joule. So define 1 joule means what? As we know in work done, what we have? In work done we have W equals to F into S. So from this we start to find What is Joule? When force of 1 Newton, we assign the force. When force of 1 Newton acts on a body and body what is not on 1 Newton acts on a body and body so displacement of 1 meter, that is the displacement 1 meter, then work done is equal to 1 joule. Whenever the question asks you define 1 joule, means you have to define 1 joule in terms of work done, not in terms of energy. Now, before that, from this we can easily write down 1 joule equals to 1 Newton into 1 meter. Now, some other units of energy are given. Old unit of energy is calorie. Still, we are using in case of some biological work. Calorie is an old unit of energy, but not the SI unit. Calorie we are using. Calorie, kilocalorie. Then, what is the calorie? The amount of heat energy required to raise the temperature of 1 gram of a body to 1 degree centigrade is known as 1 calorie. 1 calorie equals to amount of heat energy sought. Amount of heat required to raise temperature of 1 gram body or 1 gram mass to 1 degree C. This amount of energy is known as 1 calorie. Suppose we are giving it 20%. That measurement is 1 gram. When we apply heat, the temperature increased by that body. Energy received by that body is 1 calorie. Now, similarly, we have 1 kilocalorie. In 1 kilocalorie, we simply change the mass from 1 gram to 1 kilogram. And 1 kilocalorie equals to 1000 calorie. So that's all for today. You must discuss some numericals on our next class, and also the numericals given in your book we discuss in next video. That's all for today. Thank you.